So I'm going to create some services, 4 services from the schemas that we have produced earlier. Actually, the schemas that Joseph created, so not that anything I did. So I have downloaded the same files and used those for these examples. I will be using C# with .NET Core 3.1. That means that this would run on any platform more or less. I'm going to produce snapshot pull services with a simple HTTP GET. So we don't involve, you can say, the exchange that we've seen in earlier webinars. We just deliver the payload. But this exchange is still actually valid as one of the profiles that we have for exchange to deliver just a payload in a snapshot pull HTTP GET. For code generation, which I will use from the schema, I will generate code and I then will use to produce the messages. I won't do any XML stuff in my code. I will work with objects and then generate XML. And I don't want to type in all the classes manually, so I generate the code from the schemas. And for generate the code, I would use xsd.exe, which is a tool that is included in the .NET framework. It's not in .NET Core, but it's .NET framework. But since 3.1 of .NET Core, you can use the generated files in .NET Core as well. So to create a service for level A, I will start from beginning. So I will create a new, using Visual Studio. I will create a new project from the ground up, and I would use standard template for web API. We create a new project. And use one of them defined templates. I'm going to use ASP.NET Core Web Application. Hit next. And here I put it webinar 3, call it level A service. Hit create. And now it will create a project for me. Not completely empty, so it has it's a working service actually for weather forecasts. So yeah, I don't take the empty one. I take one with some content. Now it should coming, yes. Yeah, so here is the project created. And you see it has a weather forecast model and a controller that is weather forecast controller. These types or classes files you remove. And then I switch to my already created service. What I have here. And I will start with the code generation. And I usually create a command file, bat file, to generate the code from the schema, which I have now in the schema folder. And there I create this generate schema bat file. This is how I used to do, but you can do it manually if you like from the command prompt, but I usually create the command file that I can execute several times. They're hard-coded path here, so you have to adjust those to your machine. That's a drawback with this. So I have a schema path where I have my schema files, and I have an output path where I like the schemas to be, and they happens to be the same. Then I point to the xsd.exe, which is part of .NET Framework. So in .NET Framework 4.8, this is where it is located. I give a parameter /c that tells the command to generate classes, and the out is where to store the output result. And then I add the schemas, and in this case it's just 2. So if I have that command file in place, I can, from the directory, just launch the file. And we can see now that he's writing a file here, d2payload.cs. You can see that on the date that is generated now. And I have included that one in my solution. So here I have, for example, the payload publication class. And you can see the root, some attributes here added to the class. So telling that this is XML root attribute, and it should be named payload, for example. So now we have that in place. If you look at the solution in general from the example, the program, for example, is just as the template, nothing changed there. In startup, I changed one thing because we like to deliver XML. So by that, I added to the controllers method saying that we should add XML serialized formatters because it's not enabled by default. Default is JSON. So now I add XML as well. And then the real logic happens in the controller class. So here I have a controller, call it pull controller. It's derived from the controller base class of .NET MVC. And I added some attributes to this. The first one's telling that this is an API controller, and the route that configures the routing to this controller. And I changed now so that it will route by default, which means that the URL for this will be pull. It removes the controller name. So pull would be the URL. And then I have one method, pull payload. And I add attributes to this telling that I like to use, this should be accessible via HTTP GET. And I like to produce application/XML. So this triggers the serializers for XML, for example. So inside this method, then we have the things that we are, our payload. So I have the generic publication class that has been generated for me. So I create that one because this is what the payload that we like to produce. I set the lang. I don't have to set the base version because that is automatically added. I put the generic publication name, and I set the publication time to datetime.now. And I add the publication creator. And I can also add, of course, the feed type. Of course, we have IntelliSense. So that's also a reason why you like to have code generated. So you don't want to write the XML by hand. You can do it, of course, even in the code. And then we return the publication, the object. This is what I'm going to do now. And I can tell you from the beginning that this will actually not be what we want, but let's see what's happening if we run this service. Because this is all you have to do if you plug this in like this. Everything is set up by the API framework in .NET Core. So now it started my web service and automatically calls the pull URL, which will be mapped and routed to my controller. I have a breakpoint here, but I just continue and we will get the XML back, which is correct according to what we return, because we return the generic publication. But this is not what we want, because this is not according to the schema. We like to have the payload as a root element and not the generic publication. So to fix that, we have to make little changes to the code, which I included here. So to fix this, I have the thing I would like to do is I would serialize the object to XML. And then I would like to return the XML instead of the class itself, the generic publication. So I have a method created here, a utility method, which I can show. It's an extension method actually. It's static and it takes a type, any type, and it serializes this into XML to a string. So from this, I can say now that, okay, I like to have the payload publication. The payload publication has the root element payload defined. So by doing this, I get a string in the correct format that we want. But you can't return just a string, because then you would get, you would serialize the string as a content. That would be wrong. So what I do then is I create an XML document, and then I load the XML, the string into the XML document, and then I return the XML document. So if we ran this, then we would get the correct result. So what I would do now is I would deploy this to an Azure website that I have already set up. So it would be at this URL. So we just hit publish. So here we get the URL where the level A service is, and then I had to add the pull. And here we have our result, which looks much better. So here we have the payload as a root element, and the generic publication is set. So by doing this, we fix our little problem. Good, then we quickly move on to the next service, level B. And everything else is the same, except that this has, when you generate it, you have one more schema to include, the extension. And if you look at the controller, we can see that we create the extension here. So here, the extension is known to the, of course, because it's in the schema. So I can use it as an ordinary class. And then I serialize this as a previous example and return a string. So this I'm going just to publish directly to a level B service. And hit pull. And we see that our extension is coming here with a greeting, hello world. Fine. And then we take the next example, level B profile service, because here we have a little bit, not different, I would say, but we enhance it a little bit. The schema we generate looks more or less, the command file looks the same. and the controller, we now, of course, see that we don't have a feed type in the profile because it doesn't exist there. And we have the facets here, if you remember, on the greeting. But when we're doing code generation, this is not, it doesn't look at the pattern facets at all. So not even for length of strings. It could be dependent on the framework you use, of course, but I never seen a framework using it. So here I can put in numbers and anything because it will not validate that. And if we check the definitions for this one, we can see that we don't find anything related to that. Even the string here is 1024 characters, I think, but that is not reflected either at the code we have generated.
That does mean when an implementer creates his classes, actually he has to have a look into the schema to find out if there are facets or not?
Yeah, if there are some rules that they like to restrict, yes.
Mm-hmm. Because he can't see it in his
code now.
In his code.
No.
But is it in the process between what you're showing now, where you create content, and the delivery of XML on the service, isn't there a proper formal XML validation that you could include there?
I can include. I can, of course, validate against the schema if I like. The string I have here, for example, could be validated, and the XML document can be validated.
So that is the important thing. So if you could enter a check there, and then you could work on the errors. And if you don't do that, you will actually publish something which, according to the schema, is not valid, right? So that is, that's an interesting observation.
And that's what I would recommend. Always validate what you're sending out, at least in development. Usually that happens, that things hasn't been checked, I could say. I did one more thing with this. If you look at the previous example, we saw that the namespaces here looks quite odd. They are correct because they are just definitions, but they are automatically generated by the framework. So common is called Q1, for example, and exercise happens to be something else, usually. Now it's exercise. But what you can do, you can define your namespaces. It has no meaning, but it looks better when you read it, if you read it manually. So in this case, I have added XML serializer namespaces and defined my namespaces that I like to use for this type of URIs. And then I enhanced my method to serialize this into a string to use this, of course. So in this method, I has that as an optional parameter. And if that is used, I include the namespace definitions when I serialize. So by doing that, I get a string that will use my definitions. And then you can also see here that here I don't do util.serialize object. I can do it directly on the object because it's an extension method. So any object, I can use serialize object, which is handy. Okay, so if I now publish this one directly, and this time I publish this to a Linux web app. There's no changes at all locally. I just, when I created the app services in Azure, I chose Windows or Linux. That's the only difference. Of course, in which is behind the scenes here, there are probably different way he publish the files, etc. But it's nothing I see. It probably takes but I noticed a little bit longer to publish to Linux, but it's rather quick anyway. So this is running on Linux. Server error. Maybe I did something wrong. Don't think so, but maybe too quick. Yeah, also. So now we can see that we would use our namespace definitions, and it looks more as it does when we generate XML instances and so on. More readable for human, but it doesn't matter actually. It's the same result. Okay, now we've done that as well. Then we have the last one, which is the level C service. Not much different here as well. Of course, we have different schemas, different name of the schemas. But the code looks very familiar. But if you look at the schema, of course, on the generated, we can do like this, go to definitions. We will, of course, see that the namespace is level C. So here I create another class, and we can go back again then. We see that it's derived from generic publication with a normal inheritance, which what we did in UML. And then we set the greeting message as well. And serialize. So this is no different as the other. And then we publish this one directly. And this is Windows, but it doesn't matter if. The pull. And here we have the level C. And we see, of course, the namespaces. That's the important part. Is not DATEX 2. So now we have created 4 services in 26 minutes. So over to you, Ian, I think.
Yeah, so that's fantastic. So let's see whether it takes longer to create the clients.
Hello, everyone. I've been asked to show Java. I hope some of you are interested in Java. I happen to be using Eclipse, but I'm not using specifically any Eclipse features. You could use any IDE to do what I'm going to show today. I'm going to show Java code generation for DATEX 2 schemas, and I'm going to show a simple client that will access Jonas's service that he's just created. Sorry, I can't easily change the size of the thing on the left, the Explorer, but hopefully not too much of a problem for you. I can change the size of the main code window there. If anybody wants that bigger, shout out. Hopefully it's legible. So I'm going to start off with, I've just got a simple Eclipse project. All it's got in it so far are the same schemas that Joseph created and Jonas used for his services, the common and payload. So it's the simple, cut down, minimal level A DATEX 2 schemas that I've imported into an Eclipse project. So the scenario here, let's say that I know that original DATEX 2 specification. I'm writing a client. I don't know the specific extensions that Joseph and Jonas have used. So I'm not actually going to show, I guess for time, I'm not going to show the scenario where I would know those specs, but I'll still be able to access all of Jonas's services potentially to some degree, just even with knowledge of the basic level A compatibility specifications. So I'm going to use a technology called JAX-B. When you're using Java and XML together, actually you have lots of options, but JAX-B is the technology that's part of the standard JDK provided by Oracle. And I'm today using Java 8, and there are small differences. If you're using 8, 9, 10, 11, and so on, there's small differences of how you would use JAX-B. That's well documented on the web. Today it's 8. The differences are small. So the first thing I have to do is generate some Java classes, just like Jonas generated some C# classes. I'm using JAX-B for that. So normally my colleagues and I would use a tool like Maven to enter the configuration of how you do that. But just for simplicity in the demo, I'm going to just use a command prompt to do a one-off generation. So as I'm sharing the screen, I hope you can see my command window here. I'm just in the source directory for my Eclipse project. I'm going to run the XJC tool, which is the tool that's part of JAX-B, which actually generates Java from schemas. Now, what I'll do is, first of all, I'll show you just using the default, and this will actually fail, but I think it helps to reinforce a point, some configuration you need to do. So I got a bunch of errors by running XJC. What I was asking for was, please generate Java classes from these schemas. But what happens? Big bunch of errors. They're all of the same kind. They're saying that something's already in use. They're all about enums. It's already in use. And what's going on there? Well, it's because in DATEX 2, I mean, if you look inside the common schema, you see, as well as the real enum types that you have as you come across them, like precipitation intensity enum types. To implement the feature of extensible enums, DATEX 2 schemas also have these underscore things. That's just mechanics to allow the extended enums to work and still validate. And JAX-B has a problem with the underscores, or at least its default is to just ignore them, and then it has a clash. So we have to tell JAX-B to do something with the underscores. It's really simple. So what I'm going to do is, one I made earlier, I'm just going to copy into my project. A very simple binding configuration file. So this is a JAX-B binding configuration file, and I've just got one entry in it, which is to say, when you come across an underscore, treat it as a character in the identifier, and that will mean that there's no clash between the different identifiers in the schema. And that's, yeah, if you're using DATEX 2 schema generation with JAX-B at all, you will need that binding. If you're using other namespaces, there's one other binding that you may need to use as well. There's details of that are in the developers corner on the DATEX 2 website. Don't have time to go into that in detail today. I'll just show you, hopefully, the code generation really working now. So this time I'll say -b bindings.xml. So I used, sorry, I called it JAX-B, didn't I? It looks happier this time. So it's generated a whole bunch of Java classes. So I will just refresh my project and you'll see, okay, good. We've got 2 packages, 2 Java packages with Java classes inside now. Yeah, so you see, so just arbitrarily choosing a class, you see, oh, okay, here's a Java file, generated code, and it's basically got getters and setters for all of the attributes. So public holiday, that's a simple one. It's got a public holiday name and there's a getter and setter. So you can now use that Java class. Okay, what I'm now going to do is show you some simple Java to manipulate those generated classes. I have generated classes, but how do I use them? So I've prepared some very simple code. There's a simple piece of production code that I've written and a simple test to exercise that, because I always like to do things in a test-driven way. So yeah, I'm going to show some details of this code. It's pretty much standard JAX-B, very simple. So JAX-B gives you a class, standard JAX-B class called an unmarshaller. It can deserialize XML into the Java classes that have been created for JAX-B to use. So this, my class here, consider it as it's like a little simple piece of pseudo production code. The DATEX unmarshaller, it knows about DATEX XML, and it can unmarshal specifically some DATEX XML into one of these generated DATEX to Java classes. So my code, when I construct the DATEX unmarshaller, I have to initialize JAX-B and create an unmarshaller. Now, you don't need to have validation, but as Yona said, it's a good thing to have validation. So I'm also a bit of extra work to prepare validation, which is this method here. And the way that JAX-B works with validation, or one way that it can work with validation, is to use this schema, which is again it's part of the JAVAX suite of libraries. This schema facility, I tell it, yeah, my schema is, I just give it the root schema, the payload one, and I configure the JAX-B unmarshaller with that schema. So that's all I need to do to prepare validation. Then validation will be automatic every time I try to deserialize using that JAX-B unmarshaller. Okay, so that's the setup code. Then I've got a very simple, one simple like production code method, which is read DATEX payload from XML stream. So it takes an input stream, which could be from a file, or it could be from, various sources, but whatever source has been able to create a stream, and turns it into a DATEX to payload publication. And I do that just really in these 3 lines. There's actually, you can, and this is totally standard JAX-B stuff here, just asking the JAX-B unmarshaller to unmarshal. You can actually ask, there's various overloads of unmarshal. You can even call it directly on the stream. That gives you a return of type object, and you have to do some casting. So I've just chosen this particular overload where I don't need any casting, because I can tell it in advance. No, I know I want a payload publication, and I get I get a result that is known to be a payload publication, and I can return that. Then the last thing in this production code is just, well, this is like a general reusable method. Here for this demo, I know I'm actually only going to be looking at a generic publication as the kind of payload publication. So yeah, little convenience function here to read a generic publication if that's what we know we need, which just calls this method and casts to generic publication. So hopefully that's conceptually clear. Let me show the test code.
There are no questions yet, so apparently it is, Ian.
Okay, great. So test code, I set up one of my unmarshallers. That could give me potentially, I have to be able to handle not only JAX-B exceptions, but because I've asked for the validation, I have to be able to handle SAX exceptions, because SAX is there under the hood in the validation. Okay, two simple test methods I have here. First of all, I'm going to not run this test about, this is the test, the second one is the test that's really going to access live Eunice's services that we've created. But first, let me just start by something safer, which is working on a local XML file. So I did create a very totally minimal DATEX XML file, about the smallest you can have, with a generic publication. Yeah, with some mandatory attributes about who's publishing this and what time, and then the generic publication that I've said it's a name of Hello World publication. So my test that I'm going to run on this, I'm going to create an input stream just from that local XML file. And then really just one line of, this is the one line of code under test. I'm testing that method that I showed you in the production code, read generic publication. So I'll give it the stream and I'll ask for generic publication back. Then I'll really look inside the DATEX. So this assert here will actually look inside the DATEX Java object and call a method. So this generated class I've for the generic publication, I'll call a method to get the generic publication name. I'll check it's what I expect. So maybe it's most convincing if I show that failing first. So let me put in something that's like exclamation mark, right? So I'm looking for hello world publication, exclamation mark, which doesn't match my XML. And I'll run that test. That should fail. Yeah. And I have an assertion there. I can show you a little dialogue that just shows that in a larger font. Yeah, it's showing me the differences. So it's, in other words, it really is reading this local XML that says hello world publication. If I fix my test, it should go green. And I'm glad to see I don't have the performance issues that Eunice had with Ring Central. So hopefully it was just yeah, something funny with configuration.
It doesn't
good.
like Max, and you are not using a Mac.
Yeah. So now the test of that's really going to, let's look at this code. It's really going to access Eunice's service. So and this is an easier, I've been given an easier job than Eunice had to create the servers. Creating a client is a little easier. So I pretty standard Java stuff to create a URL, an HTTP URL connection. I'll say it's a get, and then I'll get an input stream from that HTTP connection. And that's good because then I can use that input stream just like I used the input stream above from a file. This time it's coming from the remote service. And I'll invoke the same, it allows me to invoke the same production code class, production code method to read the generic publication. And I think, yeah, Eunice's publication was actually, the publication name was actually called Level A publication. Yeah, so let me just show it failing as a sanity test. Now run it. It takes slightly longer than the file one, but it should be quite quick. Okay, I've got a failure. The good thing is the failure is where I'd expect it. Yeah, it's on the assertion. In other words, the DATEX2 invocation and all the Java that was generated, that always worked and was happy without a problem. But it gave me this error to say, no, Jonas's publication is actually publishing level A publication. I'll just correct that. Okay, good. And that was really going over the internet to access Jonas's service. So next, let's consider the scenario where I access the level B. So it was just as simple as changing that URL. And first of all, I'll run it without changing the assertion. That should fail, because I think that was, Jonas used a different publication name. Let's see. Yeah. So Jonas's level B actually used a publication name of Hello World publication. But interestingly, even though I didn't know the level B schema, that's the point. The point of the level B interoperability is that you have that XML level interoperability. That's this code, as we'll see in a minute when we look at something that's not valid, this is doing the automatic validation. And if there was a validation problem, it would have told me before it got to this stage. You'll see that in a minute. So yeah, okay, let's make this Hello World publication. And run that. That should pass, I hope. Yep. Okay, now I'm accessing a level B. Validation is no problem, but I didn't know the level B schema, so I've not generated Java classes for that schema. But let me show you how you can still look inside the level B, even if you don't know the schema. You can still do XML manipulation to see what's there if you want. So that's where this final method comes in that has been sitting on the screen, but I haven't talked about yet. So I'll call that. And what this method's doing, it's saying if the publication has something inside its extension, then, well, what can we do with that? We didn't know the schema. We've not generated classes for it. What can we do? Well, if you remember the schema, it's basically like in the level A schema inside the extension, it's basically like an XML any. You could see anything there. And if inside the any you find an element which is already known elsewhere in the schema, so say there was an existing type from common like humidity or special day we looked at a minute ago, say there was one of those inside the extension, then JAX-B would recognize that and give me one of those Java objects. But if it doesn't recognize it, and in this case, there was nothing, yeah, there was nothing like that to see inside the level B extension. In that case, the JAX-B just maps the things to, it basically gives you a DOM API to manipulate the XML. So if I'm writing code in advance, I don't know what's going to be there, there's not much I can do. In this demo, all I've done is basically say, well, what's the first element and what is its text content, and have a look at that. And I've done a simple assertion just to show you that we can access that. It's going to fail, but you know, I don't know in advance writing this code, what's going to be there. So there's just some arbitrary text, but I'm going to look inside that extension in the code. So let me run that. Okay, it failed but it failed at the right time, you know. So it failed just because I was asking for some specific text, you know, just artificially to show you that I can look inside in code. You can look inside the XML of a level B extension, and everything validates. So maybe to make that point clear about the validation, I think I need to show you finally the something that doesn't validate. So I'll now access the level C. run that. Okay, I get a failure, but I don't know if you can see, if you can read it, if it's very visible, but I get a failure at an earlier stage. If I trace back in my stack, it comes. In fact, it's too long on the screen, but it comes at an earlier stage. I get a SAX exception now. So basically, I'm getting an exception that it sees. If you remember, the level C had this other class. Unisys schema, which is used by Unisys service, had this class called another class, and I've asked, my code here is asking, I only knew the level A spec, I only knew the original spec, and I say validate based on the level A, and that fails because it doesn't know this other class. Okay, so that's in a way showing you, okay, in other words, this is not a realistic thing to do. You know, you wouldn't try to access a level C service and validate it if you only had the original DATEX specs, because you've got no way of doing that. You would go and find out, okay, what are these level C schemas? Generate code from them again. Run JAX-B. Don't have time to do that today, but that's what you would do. My point then of showing you is just to show you that, yeah, it really was validating the others. Until we got to level C, it was really validating, and we'd have had a problem if something wasn't valid. Yeah, and maybe just as an extra kind of proof, just to show you where this is coming up. I've commented it later, and I'll run this, and you'll still see the exception, just to show, yeah, the exception was happening when I was reading the DATEX 2, just in case you can't clearly see this SAX parse exception over here. Okay, so hopefully that was helpful in seeing some examples of Java and using generated Java classes to access DATEX 2.